Hi there once again. I hope you're well and that we are ready to listen to the next video. In the last video that we were talking about exothermic reactions. I'm going to continue with the series. I'm going to be talking about your endothermic reactions in this short clip. Just a quick brief overview of what we looked at when you looked at your exothermic reactions. You had an energy profile, and that energy profile contained your potential energy and the energy that is that the reactants have, and then the activated complex and the product. And what was key and important to note and observe was that the energy content of the product is lower than the energy content of the reactants. So we're going to do something similar with the energy profile for an endothermic reaction, right? So by definition, what is an endothermic reaction? An endothermic reaction is one in which energy is absorbed from the surroundings into the reaction system, right? So your endothermic reaction, just like your exothermic process, also has an energy profile. So with this energy profile, it's important to label that. So this is the potential energy of the reacting particles, and then you've got the extent of the reaction, how long or how far the reaction is continued, or the time that it is taking to occur, right? And so when you start off, you've got to have the energy of the reacting substances. What energy do they have? So let's say this is the energy content. Maybe it's a bit too high. Let me just maybe take it from here. The energy content of the reactants, right? How much energy do they have? So your reacting substances, let us say it's substance P and substance Z reacting, and then they too need the activation energy. All reacting substances need activation energy in order for them to participate or form a product in a reaction. So what you're going to observe in this particular case is that the products have got an energy content which is higher than the energy content of the reactant. So that is important to observe. So therefore, when we now calculate your enthalpy change for the reaction, delta HR, it will be important to recognize that that's the difference between the energy of the product minus the energy of the reactant. H of the reactants. So that is going to be interesting. We're going to discuss that as well. What we would like to remind you is that from the reactant right up until you get the peak of the activated complex, what you have is the difference between those, and this is your EA. And what is the EA referring to? EA is the activation energy. Again, take note that this process from the reactants to the activated complex, which is at the top, right? The process is an endothermic one. It takes in heat from the surroundings. And then energy was then when the bond formation. So this stage here is bond breaking. And then this other process from here to where the products are, that is a bond forming step, right? So during that bond formation, what is happening? Energy is being released to the surroundings, and during the bond breaking, energy is being absorbed from the surroundings. Which bonds are being broken? The bonds between P particles and also between Z particles. And then which bonds are being formed? The bonds that are being formed are for the new product PZ that's going to form when P and Z have reacted, right? So it's important that you realize that there is bond breaking and bond formation, and that these two are opposite in nature in terms of the absorption or release of energy. Now, the delta H of the product, you will appreciate it that the energy content of those products is a higher value than the energy content of the reactants. And let us say, hypothetically, we say that this is 67.5 kilojoules per mole. That's in kJ per mole, right? And then this here, let's say the energy content is something like, for argument's sake, 43.4 or 0.3, 43.3 kJ per mole. You can then work out the delta HR of the reaction, the enthalpy change of reaction. So this is the energy that's either absorbed or released when the products are formed. So now what are we going to have so that we can make that conclusion whether it's absorbed or the energy has been released? We look at the value of the energy content of the reactant of the products is 67.5 minus your 43.3, and then when you do the calculation, simply call up your calculator and then you can make use of it. So when you are doing the calculation, what you're going to get is your 20, it's not your 20, it's clear that 67.5, 67.5 minus 43.3, and you're going to get the value of your calculation as 24.2, which is going to be 24.2 kilojoules per mole. Now, what do you observe? This value here is positive. Okay, what does that positive mean? You've got to give meaning to that positive. This positive shows us that energy, 24.2 kilojoules per mole of energy, is absorbed from where? Is absorbed from the surroundings. So if you were to touch the container would feel colder for the simple reason energy has been drawn from it, and hence it's going to be left with a lower temperature than what you would have experienced if you were looking at an exothermic reaction. So it's important that you give an interpretation of that plus, and you use it to answer the questions. At times you can be given an equation, and then when you're given an equation, let's say they say to you P plus Z gives you PZ, and then they say to you delta H is greater than 0. You need to be able to give the interpretation of that greater than 0. When it's greater than 0, it obviously means that delta H or delta HR for the reaction is a positive value. It means if it is positive, we have told you what that means. It means that the value is is denoting that the process is an endothermic reaction. So very important that you look at that. Very important that you are able to compare these two graphs when you look at the exothermic as compared to your endothermic process. So your exothermic, in your exothermic, the energy content of the product is less than the energy content of the reactants. Very important that you remember that. Thank you for watching. If you like this video, please like, please share, and please subscribe to our channel. We will be giving you another video on how the influence or what the effect of a catalyst is on an energy profile that can be given to you. Look forward to seeing you the next time. Please like, please share, and thank you very much for watching.